Okay, today I'm going over maybe an easier example of figure 7.5 in their book, and I'm going to show us some shortcuts on if we get stuck in a loop, things that we can do to get out of it or to reset it. So please listen carefully to this. Start with just a simple string like input, and then we're going to have a while loop. So while, and exclamation means not. So while input dot equals, ignore case, so remember it's not case sensitive there, exit. So as long as they don't enter exit, it'll keep looping on them, and we should have 6 parentheses. 1, 2, 3 left, 1, 2, so we'll need a third right. And I think we'll end up with 2 loops on this one. So then I'm going to have something like, since we'll need some sort of input, specifically filling this variable to check if they enter input, we're going to need a J-option pane in here. So I'm going to do input equals J-option pane dot show input dialog. You're in the outer loop. Enter exit to exit, or enter to get to the inner loop. Then I'm compile, just make sure I haven't made any mistakes. All right, looks good. So I'm going to put a second loop in here. So while input dot equals, lowercase, enter, and notice we only have 2 sets of parentheses there because I'm not using the not option. So I'll copy this. You're in the inner loop. I'm going to get rid of this because we're not going to give the user the option here of inputting something, but we can still get them out of it. So it says you're in the inner loop, and we'll get rid of that. So compile that. And let's check this error. Cannot find symbol input. Let me check my spelling and all that. I spelled equals wrong. Okay, if I were to run this, I can type enter, and I'm in the inner loop. No matter what I type, I'm stuck. So a way out of that, really easy, is just to use the word break, semicolon, and it will force us out. I'm going to change my message here. You're back in the outer loop. So let's compile and see if this works. I'll go enter. We're in the inner loop. And then rather than looping again, we're back in the outer loop. So that works. And then our outer loop re-looped as well. Now say we didn't want, maybe we had an if statement here. If something happened, maybe we had a lot more code in this area. You can use if statements, like based on, maybe ask the user a question. And if they say something that appropriate, you can break them out of that loop. Or say you wanted the program to completely shut down from there, you can use this. System.exit 0. And that shuts the program down, and 0 means it kind of cleans up all the memory, cleans up after itself. And these aren't things you need to memorize. You can just always ask me in class, hey, what was that thing you mentioned? How to exit a program, and I'll tell you. So let's test this. So we'll type in enter. Hit OK. We're in the outer loop. If I hit OK, this should execute, and the program will end. Yep, there we go. So that's another option. Now, say you ever needed to force a program to restart, or a loop, not a program, or a loop to restart, rather than break out of it, you can use the word continue. Semicolon, and when it hit this line, it would immediately jump right back up to here. Now, if it's looping automatically, that doesn't matter, but you might have some situations where, say the user entered something incorrectly, like maybe with our password program, you could bounce them back up and have them re-enter something. So that is certainly one option. Okay, I'm going to put a break back in here. And one thing I want to show you next is something called scope. Scope means, when you think of all these curly braces we have, they don't necessarily share information outside of them. So something between here won't necessarily be shared outside of it. For instance, if I do integer x equals 4, and I wanted to print that down here, let's see what would happen. Okay, so it says it cannot find symbol, and it's referring to variable x. So that's a question of scope. It's just like if Mr. Carruthers went into room 172 and announced that we were having a snow day. Well, we're in room 166, so we wouldn't get the message. This is room 172. We're somewhere else, so we don't get it. So to do that, you have to declare what are called global variables. And we've been doing that all along. That's why we declare our variables up top. Because when they're just past the main method up here, everything here can share them. So we could use it anywhere in the rest of that program. So let's see if this works. And then we'll see if this actually changes it. Now that won't, because we'll break out of it beforehand. So let me add that there. Let's compile. Let's execute it. So I'm going to go into the inner loop. Now, if we don't go into the inner loop, it probably would never change to 4, because we would not execute that statement. So we're in the inner loop. We're back in the outer loop. Hit OK, and x equals 4. Now, you've all seen, this is cool. This is how lazy programmers are. You've all seen this before. X equals x plus 1. To programmers, they consider that a bit of work. So if you ever want to just count by 1, say you're like keeping track of how many lives in a game, and it usually only goes up or down by 1, or points of some kind, and like maybe a game of ping pong where it's only 1 point at a time, the shortcut for x equals x plus 1 is simply x plus plus. Now, because they're lazy as well, say they wanted to, in a video game you lose lives, rather than subtracting x equals x minus 1, you can do x minus minus semicolon. You don't have to use these. They're just shortcuts. I encourage you to be as lazy as programmers. And these are called incremental, if you're adding, or if you're counting down, decremental operators. You don't need to memorize that. And let's see if it works. We should get 4 to print out yet again. Just to make sure I don't test that properly, I'm going to change that to 3, so we should get 2. In the inner loop, back in the outer loop, and I'm down to 2. So notice this global variable declared up here, right at the top after the main method, is accessible by everything here, and we can easily add or subtract from it.